Hi, I'm Chuck Bender, and welcome to CNC Basics. So here's the thing. I've played around with a couple of different CNC machines at shows and at a couple of shops and things like that. I've played around with some of the Next Wave automation stuff here and there, Axiom Precision, ShopBot, and now I get to play with Hammer's new HNC, which is a really great little compact CNC router. But the reality is, I don't have extensive experience at this. And that's part of what this class is about, is to show you that, hey, you don't need a whole lot of experience as a woodworker or as a computer and CNC operator in order to get this stuff figured out and start making some really cool little projects in your own shop. So first of all, you're going to need a few things to get started in CNC. Well, number one is a CNC machine, and they come in all different sizes. This happens to be the smallest one that Hammer is making. In fact, it's brand new, and Felder, the parent company of Hammer, has been making industrial grade CNC machines for a very long time. And the great thing about Felder is all of their Hammer equipment basically is trickle down technology from their higher end stuff. So what you're getting is Austrian precision built into this tiny little compact CNC router. Now, that's not to say that any of the other brands out there are not viable brands. They're just different. You can get them from a lot of different places. And we're going to go through a lot of the different things here in this class over the next half hour or 45 minutes. But I'm going to tell you that I'm going to avoid as many of the screen captures on the computer as possible, because what I found is they've all got their own controller software that they proprietarily use to run their own CNC machine. So for me to just sit here for the next half an hour or so and show you how the software that controls this particular CNC machine is going to work isn't going to really help you out very much at all, because you may not have the same one. I mean, I kind of hope you do, but if you don't, then it would be sort of a wasted period of time. So we're going to talk more generic terms. I'm not going to teach you, for my design program, which you're also going to need, you're going to need a design program, something like CAD. I use SketchUp. I have SketchUp Pro. So it allows me to export my 3D models as a DXF file. And for this particular thing, I've signed up for Fusion 360, which in itself is a pretty good design program, but I'm already comfortable using SketchUp, and I didn't want to spend a whole lot of time learning how to model in Fusion as well as do the CAM, which is how we turn those 3D models into tool paths for the machine to follow. So you're going to need not only the CNC machine, some kind of design software, and then you're going to need some kind of CAM software to convert those designs into the program that the CNC machine will then read and execute. The other thing you're going to need are some spiral bits, some end mills, whatever you want to call them. Router bits function as well. These happen to be a group that the folks at Felder have been using with this machine. This machine has been in their showroom now for a few months, and they've been playing with it. And if you are anywhere in the area and you want to trek to Newcastle, Delaware, if I give it back, you might be able to go down there and play around with it in their showroom, or at least have a good demonstration of it. So they gave me all of these. What I did was I also looked at some of the basic sets that you can get from Amana, Whiteside, Infinity Tools, things like that. You can come up with some basic, for the most part, spiral down cut end mills. What we're going to use in the class today for the first demo is a 3mm spiral down cut bit. They all have 1/4-inch shanks on them. The machine comes with a 1/4-inch and an 1/8-inch collet, but I wanted to just stick with the 1/4-inch stuff. I don't really have a whole lot of use for the 1/8-inch cutters at this point, particularly since I was only going to be doing 3 or 4 complete projects here over the course of the month of woodworking shows. So what we've got are a whole bunch of 1/4-inch spiral down cut and up cut flat end mills. So they're just flat on the end. There's a couple of ball nose end mills, and which I didn't use at all in this demo or any of the demos here. They've got a 3mm ball nose as well in their group, and some of the sample programs that you have access to use a V-bit. So I could see if you're starting out and you want to get a core set, I could see 1/8-inch and 1/4-inch flat end mills, 1/8-inch and 1/4-inch ball nose mills, some small V-bits, and if you're going to use it to create any kind of molded profiles, you'll need the specific molding bits. You'll go from there. But I think really, if you look at Amana's core, they have a basic set, and it looked like it was fairly good. The other thing that I didn't do was I didn't turn around and look at this machine in terms of milling an entire surface off. So they do make larger diameter milling bits that you could potentially use for this. So if you were also going to use your CNC machine to flatten slabs, you would need a larger milling bit in order to be able to do that. Now, some of this stuff is very specific to this machine because this is the first one I've had in my shop. Like I said, I've gone to places where I've gotten to play with other CNC machines, either at shows or in workshops or in retail operations here and there, particularly back when I was an editor at Popular Woodworking magazine. I got to travel to a couple of different places and play around with some of these things. This machine, as it comes through, is not too terribly different than most of the others in terms of what you get. So you get the bed, the gantry that slides back and forth and moves up and down. This has Hammer's base router on there. You can also get it with a spindle, which is basically a much heavier duty router, and quite often they are the motor is cooled in some way. They're a lot more it's a lot more expensive. Usually a spindle's 2 to 3 times what a router would cost. I know from talking to the folks at Felder, their spindle is just about double what the cost of the router is. It might be worth it if you plan on spending a massive amount of time working on your CNC machine. It has some kind of a computer interface. Oh yeah, you're going to need a basic computer too. I had to dig out an old Windows machine. I've been working on Macs for a long time, and I really didn't want to throw Windows on my Macs in order to do this. I did throw SketchUps on my Mac, and I also threw Fusion 360 on there so that I could handle the cam work on my much more powerful Macs than I could on my kid's old Windows PC. It is running Windows 10. It's not, when I tried to run Fusion 360 on here and the Eating controller software, and that's the company that they're working with here at Hammer, the computer tended to lock up and freeze up a whole lot more often. So at this point, the only thing that I've got lots of other programs on there, but the only thing that's active at the moment is the controller software specifically for this machine. there's an interface that allows me to patch from the computer into the CNC machine via USB. And hammer also comes through with this emergency stop button, which the only time that I've needed it in the last few weeks of playing around with this thing, I didn't get to it in time. So I just shut it off on the computer. So let's take a look real quick. When we start, what I liked was Felder gave me this really neat little spiral bound step-by-step set of instructions for setting up the machine, and I wanted to go through some of it without getting too crazy. And my computer just shut down. All right, there we go. Because once again, some of this stuff is going to be very specific. Generically speaking, or generally speaking, whether you've got a CNC Shark, an Axiom Precision, a Powermatic CNC machine, or the hammer, they're going to give you either some way to load up your software onto your computer, or they're going to give you a link that you can go to the web and download the controller software. And at that point, you will load and install. And that's the first things that the step-by-step spiral bound book from Hammer comes across with is their links to their website. You download it. It tells you every step on how to get the software installed on your computer. Now for me, like I said, this stuff is Windows based. If you're going to do the design work, the CAM work, and run the controller software all on one computer, you're going to want to make sure that you're not operating off of about a 10-year-old Windows PC with only 4 gig of RAM. You're going to bump that up because most of the software really requires that you have a good bit more. Spend some time playing around with the software. The first thing I did once I got it hooked up to the CNC machine was calibrated the machine, brought everything to the home position. Right now I'm not going to do it. In fact, I have the CNC turned off so that I can't inadvertently hit a button and have it go sliding all across here. I don't have this is the dust shroud that's on this one. It just mounts on there. I wanted you to be able to see what the router looked like without all the dust shroud in the way. I have my shop vac hooked to it, really easy to do. And seriously, the software, the operating software, the basic operations are pretty simple. Through some keyboard shortcuts here on this software, they use the up and down and side to side arrows and the page up and down for the most part for controlling the position of the router and consequently the bit based on how you do that. You have ways to jog the router up and down, left and right, forward and backwards in very specific increments. Again, pretty intuitive stuff. Most of the software that I've seen for other CNC machines is very similar in the end. They have some way to fine adjust because once you get your work clamped down to the table, you're going to have to figure out, depending on how you designed your project, you're going to have to determine an origin point, which is where the router bit is going to start. So for me, I chose that origin point in the CAM software by picking either the center of my project. So if this booklet were my project, I would either pick the center or I would pick one of the corners, and I usually worked off the top surface because that's the easiest way to set up the machine. And you'll see when we get to this next step exactly how I go about setting that up. I think the best way to get started on this is we just jump right into the very first little project that once you've got your computer software installed, you've got it hooked to the machine, you've tried to run it around for a little bit, load up that example program that they give you or send to you. The one thing that I did was I took the router and set it about an inch above the surface of my work surface for the first run. And that's where I set my 0 point. And then I let the computer run the software, which means it went through its entire cycle and never touched the actual project at all. I just wanted to make sure that the router motor itself was centered properly on the work and all of that kind of stuff. I didn't even have a router bit in it to begin with. So safety first, run it dry, make sure that you're sort of hovering over the general work piece, then set up the router bit and dial it right in and run. So let's get started on the very first little example project that Felder gives you along with the Hammer HNC. So the first thing I'm going to do is install a 3mm spiral down cut bit. So what I do once I click the collet into the retaining nut is set it down on a flat surface and insert the bit until it bottoms out flush with the bottom of the collet. Normally, if this was just a regular router, I would leave some space between the bottom of the bit and the bottom of the collet, but there's plenty of room up inside the spindle on this router. So all I have to do is lock the spindle, I like to thread it up until it comes to a halt there, and then I'm going to give it maybe another quarter or a third of a turn, or make sure that the router bit is locked in solidly. For right now, I can just randomly place the vacuum attachment, and then we're going to work on our next bit of setup here. So the other thing I want you to notice here is the vacuum just has a stud on the top of this plate, and I attached my shop vac using a Fernco coupling that has a couple of small hose clamps. So the other thing you can see that I have to deal with is my plywood has a little bit of a twist to it. Not sure exactly how that happened. It must have just been sitting someplace odd. The bed of the CNC machine has all of these parallel T-slot grooves in there, and I know that they are running parallel with the sides, as well as the gantry is perpendicular to those slots. So what I've done is I've sort of centered my 400mm board, which is what the plan called for, was a 400 by 400mm piece of half-inch plywood. Unfortunately, I didn't have any half-inch that was that size, so I'm doing this out of a piece of 3/4. I've got a couple of makeshift clamps here that I put together when I picked up the CNC machine at the Felder showroom. I seem to have forgotten to pick up the clamps that went with it, so I've just got a couple of T-bolts and some threaded knobs, and then just a piece of steel bar stock. This one has a couple of studs on it, but the important part is it's got a hole, so I can run the T-nut up in there. One of the things that I want to do once I get a few projects under my belt is I've drawn in SketchUp a couple of really cool clamping blocks for here that I would like to make out of some nice hardwood to clamp down the four corners of my my work when I'm working on smaller stuff. So if you take a good look here, I'm just barely hanging on. I've got maybe a 1/16 or so catching on each one of these corners. I don't have these locked down too terribly hard because I don't really want to mar up the surface of the bed, and it has pulled my plywood down nice and tight. So the next thing to do is I'm going to load up the program, and then I'm going to return the gantry back out to the home position. So I hit the home all button, and you'll see it starts with the Z axis. It's going to bring it all the way up. And as we're looking at it, it will then move the router all the way to the right side of the machine and then bring it forward. And now the CNC machine is ready. I can load up into the controller software the program that is actually going to make my test project. I loaded up the program after homing my machine. So now what I need to do is find the center of my 400 by 400 millimeter piece of stock, because that's where we're going to move the router bit to get this set. So on this controller software, if I use the left and right arrows, it moves it forward and back. If I add the shift key, it moves at full speed. If I use the up and down arrows, down takes it to your left. And again, shift key makes it move at full speed. Page down or page up will slowly move the router bit up and down. Add the shift key. All right, so I'm fairly close, but my increments are still too gross for moving this thing. So what I'm going to do is use a command that they have. There's a toggle button that allows me to jog this, and I can do it down to about a 10,000th at a time. So I'm going to start by doing it at 100th. Let's try a 10th instead. Fairly centered front to back. Let's take it down. Needs to actually come forward just a tiny bit. Front to back, I'm now good. I just need to get the height set. I need to bring the router bit down so that it just makes contact. I'm now a few thousandths off. I can take it forward just a touch. All right, I'm touching and I'm centered on my piece. At that point, I can go back into the program, zero out all three of my axes, the X, Y, and Z. And then what I'm going to do is raise it up high enough that I can go back and add the dust shroud and get that adjusted. And all we need is about 1/4 of an inch, maybe even a little less. It's only going to go into this material, I believe, about 2 millimeters. So 1/8 of an inch would be plenty. I think we're ready. So let's start the vacuum and hit the start button on the program. So as you can see, the program worked perfectly. I think it came out pretty good for my first ever honest to goodness project on a CNC machine. So let's see if we can't kick this up a notch. I'd like to actually design something simple myself and see if I can get the machine to actually make it. It'd be nice to cut a couple of parts out. So let's give it a shot. I started by drawing two 30, 60, 90 triangles, extruded them out to 3/4 of an inch thick, and then inserted 2 holes in each. I exported that as a DXF file, brought it into Fusion 360, and at that point I used the CAM program to do 2 setups. I did a 2D pocket, which gave me all 4 holes in my 2 triangles, and then I used the same setup, added another layer for a 2D contour, which allowed me to cut out the outside perimeter of all of the pieces. Once I was done, I exported it as a CNC file, and now it's time to load it up and run it. Now that I'm ready for my very first custom project, I've clamped the board down to the table because we're going to be routing entirely through the material that we're going to make the triangles from. This just happens to be the Felder logo that I turned upside down. So I've got my piece of 3/4 inch Baltic birch plywood that is 13.5 by 13.5. Even though the triangles are only 12 inches long, I want plenty of room so that there's no way I can run into the clamps. I'm not exactly sure how on a regular basis I'd like to attach projects like this to a sub base. So this time I'm going to jump right in to using some double face tape and just see how well that works. Four strips of double face tape here will not only keep the material down to the table in its entirety. But once the router cuts through and separates the parts, those parts won't go flying across the room either. So I want to keep everything down to my sub base if I can. When I clamped down my sub base, I made sure that it was relatively square and parallel to the ends and edge of my CNC table. This way, when I attach my stock, I can make sure that it's relatively parallel. Press it down, give it a tug, make sure it doesn't go anywhere, and now we're ready to give it a try for our very first custom project. So just like before, the first thing I need to do is send the machine all the way back to the home position. And now that it's in the home position, I want to try and get it over to the start position, which is on the far left corner of my stock. I can raise the cutter up, and I'm ready to begin. So as you can see, I ran not only the 30, 60, 90 triangles, but I also ran a set of the 45, 45, 90 triangles that I had run. These I still have to peel the tape off of. It comes off fairly easily. What is really sort of weird is you get this residue coming up the sides from that end mill. And it also leaves a little bit of fuzzy stuff on the bottom edge because, well, it's a downcut bit. So I'm going to have to get rid of all of that stuff real quick. And I want to do a little bit of sanding on these. So if I get rid of that stuff, like I said, you can see a little bit of fuzz around those edges. The surfaces, even though it's plywood, are really nice and smooth. That's because of all that accuracy you get with the machine. So if I just take a little bit of sandpaper, I've got some 220 grit here, and I should be able to just knock off any of the extra residue from the tape. If I'm having trouble getting, like, there's a spot that the residue is really thick and kind of pasty. So what I'll probably do is grab a little lacquer thinner, naphtha, might even do some denatured alcohol on there. But I'm going to clean these up and put them to use in another seminar. And if you were already here for the bevels, chamfers, and miters class earlier, you've already seen these in motion. So you already know that I cleaned them up and I got them useful. So thank you for coming. I really hope you enjoyed the basics of CNC work. These are pretty simple projects. So next week, what I plan on doing is upping the game a little further. You know, these were just some plywood triangles with some cutouts in them. They're not really parts of a piece of furniture. And for those of you who think that using a CNC in traditional woodworking is absolutely cheating, I'm going to show you where this 18th century furniture maker would really love to be able to employ that machine, that tool, to make my job a whole lot quicker, more efficient, and enjoyable.